Hello everyone, welcome to the session on GenRocket integration with Selenium. In this journey, we are going to see a simple use case and its test data challenges, followed by a quick overview on GenRocket project setup. From there, we will learn various approaches on GenRocket integration. Specifically, we will uncover the secrets of how GenRocket's seamless data generation happens from Selenium automation scripts. The important prerequisite required for this integration activity are Selenium setup, which helps to create the automation scripts, and GenRocket to perform the synthetic data generation. We highly recommend familiarizing yourself with GenRocket and Selenium tools by referring to their respective knowledge base portals. Let's kickstart the journey by taking a closer look at the GenRocket Bank application, a demo application provided by GenRocket. In this scenario, we shall assume a role of admin persona who enters into the application in order to add a new user to the system. This process involves filling out a form with the user's information to create a new record with a positive dataset, whereas the negative dataset like incorrect SSN and birth date less than 18 years results in error message. So the test data challenges here are: variety of data combinations are required. Data including positive, negative, and edge cases with condition data is required to validate the workflow and the error messages. GenRocket is the ultimate solution to overcome all the test data challenges, offering seamless support for data generation and setup in any volume, variety, and format. Prior to integration activities, it is essential to configure the test data project. Once the base project setup is done, GenRocket provides a capability to create the test data cases called G-cases. G-cases are one of the GenRocket's intelligent and powerful feature, allows us to generate the data based on actual test case need. Defining negative G-cases are easy because you get to control and design the patterns on how negative data needs to be generated. For example, you could see that we have linked 4 different generators to generate the invalid SSN. As a result, every fourth data in the dataset generates an invalid format SSN data. Also, even before the actual data generation, data preview feature allows us to visually validate the data to be generated. Great progress so far. Let's deep dive into the most awaiting section: various approaches on GenRocket integration. Although GenRocket provides multiple approaches for integration with other applications or tools and framework, in this video we shall primarily focus on 2 key approaches. The first approach is using GenRocket runtime APIs, where we can access GenRocket components directly to run or modify. And approach 2 is using GenRocket multi-user server and the REST calls, designed to handle multiple user requests to execute and generate data simultaneously. For the ease of understanding and clean view, we would be using Groovy as a coding language to demonstrate the integration. However, in the end, we would show the same piece of code in Java as well. Remember, we have designed 2 G-cases in our GenRocket project. The first G-case, called negative dataset, generates the invalid dataset for SSN and birth date, whereas our second G-case, called positive dataset, generates the positive data for the happy path scenarios. Fasten your seatbelts as we deep dive into the integration approaches. The first approach is about using GenRocket runtime APIs, which is simple and straightforward. Import the GenRocket engine and define necessary variables. Initialize the GenRocket engines, followed by load GenRocket scenarios, and then add the G-cases on top of the loaded scenarios. For less complex and memory-intensive data requirements, GenRocket recommends using the Scenario Run in Memory API. It generates and stores the data in memory, speeding up the test execution by eliminating file read and write operations. Alternatively, for data requirements in any file format, the Scenario Run API can be used. It's time to run the GenRocket scenarios. Fantastic! GenRocket components are triggered to generate and store the data in memory for the automation scripts. Now, for negative test data generation, replace the positive dataset G-cases with negative dataset G-cases. Easy. Hold on to your breath. The second approach is even more powerful. In this approach, we follow 3 simple steps. During execution, a REST request with payload is sent from Selenium automation scripts to GMS server. Then GenRocket multi-user server executes the scenario and generates the data. In the end, a REST response is sent back to the Selenium. Let's deep dive on how to integrate using GMS and REST API from our code base. Import the required dependency jars for REST API calls. Define the endpoint URL and payload. If the in-memory parameter is set to true, then the data is generated in memory only. Initialize the HTTP builder and the REST post calls to GMS. Final step is to capture the response from the GMS. Before we trigger the execution, ensure the GMS server is up and running in your environment. All set, let's run. Truly amazing. We have seen how powerful and easy it is to integrate GenRocket. Let's quickly see how GenRocket integrated in the real-time Selenium projects. In the automation test case where the test data setup step is performed, we need to call the GenRocket components to integrate and generate data at the runtime as per test case need. Let's execute the Selenium test cases and witness the magics of GenRocket in action. The most fascinating aspect of this journey is GenRocket integrates at the test case level and generates data precisely tailored to meet the requirements of each test case. This ensures the test data aligns perfectly to each test case and enhances the accuracy and effectiveness of the testing process. Congrats, we have seen successful integration and execution of GenRocket with Selenium. Thank you for watching GenRocket Solutions video. For any queries, please reach out to our knowledge base and support team.